Cryptography was with me my whole life, and it all started back when I was a grade schooler.
Alright, today class we'll be learning about cryptography. We'll start off the day by doing the bell ringer like usual. Excuse me, Minnie, but there's no passing in my class. Why is math so boring? Well, I know you're really great at math, Minnie, but because you're no passing, I'm just gonna have to send you to the library. Fine. Justin, you go with him too.
What?
Okay.
Why did I get sent to the library?
Hey Justin, check this out. We can create our own encoded messages through this weird thing called cryptography.
Whoa, what is cryptography?
Cryptography is messages according to a secret code, and this thing has been around since the use of hieroglyphics carved into tombs from the Old Kingdom of Egypt. We can utilize matrix multiplication to encode and decode messages. The number 1 through 26 stand for the universal coding letters, and the number 0 indicates the space between words.
So A represents 1 and Z represents 26?
Exactly.
So how do we encode messages then?
Well, look at this example here. We can take the message "Meet me Monday" and write an uncoded row of matrices with the dimensions 1 by 3. So we start off by writing the matrix 1355 because these letters correspond with the universal coding letters, and so on and so forth. After we get our row of 1 by 3 matrices, we can use an invertible n by n matrix to encode our message. We multiply these matrices using the row by column technique. Alright, so we use the row by column theorem to get our encoded message. So 13 times 1 equals 13. 5 times -1, -5. And 5 times 1 equals 5. Added together, that equals 13. Now we do that to the next column. 13 times -2, -26. 5 by 1, 5. 5 by -1, -5. That equals -26. And then we do that to the final column. 13 by 2, 26. 5 by 3, 15. And 5 by -4, which equals 21. And this will result in the coded message.
Hello, who is this?
This is the British government. Is this Minnie Cox?
Yes.
We need your help to decode these German ciphers.
Okay, but I will need help, so I'll make my own team.
Okay.
What is this? Oh wait, this is pretty easy. You are in?
Minnie? Long time no see. Welcome to the team.
Oh, Minnie, we need you to decrypt these ciphers that we intercepted from the Germans.
How did you get these? Alright, I'll do what I can.
How'd you figure it out? Well, let me show you.
First, we need to find the inverse of the encoding matrix. If you see here, I joined the encoding matrix with the identity matrix in row echelon form.
What does this have to do with finding the inverse of a matrix?
Well, we can obtain the form I inverse A through elementary row operation. So let's start by adding row 2 plus row 3, which equals new row 2, which equals this, and row 3 minus row 1, which equals new row 3, and row 3 plus row 2, which equals new row 2, row 2 minus row 3 equals new row 3, and then we go put negative sign on row 3, and row 2 plus 7 row 3, which equals new row 2, row 1 minus 2 row 3, which equals new row 1, and finally row 1 plus 2 row 2, which equals new row 1. Thus we found the inverse of the encoding matrix. I multiply this inverse matrix to the coded matrices using the row by column technique that we learned earlier. And these are the decoded matrices. And after matching this number to the universal coding letter, I decoded the message.
Wow, how have I never thought of that? You're a genius.
I must get to the government facility now. Says bomb tonight.
Alright, I'll report to the officials. Good work.
In Chicago, tears of joy mingled with cheers as 1 million people sang and danced in the streets. In Seattle, it was wine, women, and song, mostly song as serviceman and civilian threw dignity aside. This was the time to whoop it up.
And that's how the cryptography helped us win the war, son.
Wow, that's a really great story, Dad. Can you teach me how to do it?
Sure, old sport. But remember, it is important to know how cryptography can be used in real life situations. Okay.
Why did I get sent to the library too?
Oh shit, the books. We can create our own encoded messages through this weird thing called cryptography.
What is cryptography?
Cryptography is message according to a certain...
What are you doing?
Get me out of here.
Oh my goodness.
This guy's gonna be like, Crypt. Aw.
Hey Justin, look at this. We can create our own encoded messages through this weird thing called. Hey Justin, look at this. We can create our own encoded messages through this weird thing called.
Justin, look at this. We can create our own encoded messages through this weird thing called cryptography.
What the? Oh shit.
Why did I use that to the library? The book's open!
Done. Go. Hello, is this Mini Cox? Oh shoot.
Oh my god!
Answer yes, I'm the second line. This is the British government. Is this Mini Cox? We need your help to decipher these. Not decipher, decode. Mini, we need you to decrypt these ciphers that we intercepted from the Germans.
Dude, stop it.
You want me to take it?
No, do I go on in front?
Like, that's useless!
Eureka, figured it out! Stop. Where you at? No.
Why?
I don't know. I'm gonna screw up, I know.
No, like in a couple of tries, I think you can do it.
Yeah. First, we need to find the inverse of the encoding matrix. If you see here, I'll join the encoding matrix with the identity matrix in row echelon form.
What does this have to do with video?
Oh my god.
That's me! It says J! Not M! Oh my god.
Hey, we're doing fine. Form I inverse.
I inverse A!
Well, we can.
Please get past that part.
I figured it out!